Could a mountain of foul-smelling waste save millions of hectares of the Amazon rainforest? Every year, Brazil processes over 670 million tons of sugarcane for sugar, leaving behind enormous piles of bagasse. For hundreds of years, its fate was simply to become cheap animal feed. But then, Brazilian engineers performed a miracle, transforming this waste into pristine, smooth sheets of white paper, a complete replacement for natural forest wood. So what industrial magic transformed this rough waste into everyday writing paper? When you think of sugarcane, you probably immediately think of sugar production. But few people know that after the juice is extracted, the remaining material is called bagasse. This seemingly useless waste product actually contains about 50% cellulose, a crucial component for paper production, which is also the fiber harvested from wood. Therefore, instead of being burned, Brazil has pioneered the technology of processing millions of tons of bagasse into paper, helping to reduce the pressure on natural forests like the Amazon. Paper produced from bagasse accounts for about 5% of the total paper produced worldwide each year, equivalent to about 10 million tons. Essentially, the sugarcane bagasse used for papermaking is simply the fibrous residue left over after the cane has been crushed to extract juice for sugar production. Consequently, the journey of a sheet of bagasse paper always begins in vast, sprawling sugarcane fields. Sugarcane thrives in tropical and subtropical climates, such as in Brazil or U.S. states like Louisiana and California. The stalks typically contain about 16% sugar, but up to 55% cellulose, making them an ideal raw material for the paper industry. After a growth period of approximately 18 months, the sugarcane is ready for harvest. Massive harvesters slowly advance into the fields. At the front, two rotating cutting discs slice through the base of each stalk just above the ground. Simultaneously, large rollers grip the stalks and pull them into the machine. The tender tops and green leaves are trimmed away, while dry leaves and sheaths are blown back onto the field by a high-powered fan system. Next, the stalks pass through a high-speed chopping system that cuts them into segments roughly 20 centimeters long. A conveyor belt atop the machine continuously transfers these cane billets to a trailer or truck driving alongside. In a single day, a modern harvester can process about 6 hectares of sugarcane. Trucks laden with sugarcane must quickly leave the field to transport the raw material to the sugar mill, as the sugar content in the stalks degrades over time due to plant respiration and microbial activity. It is here that the bagasse is produced. Trucks laden with sugarcane quickly pull into the sugar mill's raw material receiving area. Here, the freshly harvested cane is dumped into massive receiving pits capable of handling hundreds of tons per hour, ensuring the production line runs without interruption. From this point, a heavy-duty conveyor system takes over. Steel chains and large drag bars slowly pull the cane bundles out of the pits and move them deeper into the factory. Overhead, a rotating cane distributor helps separate the stalks into a steady, uniform stream. This device continuously rotates and sweeps across the conveyor, breaking up tangled bundles and maintaining a consistent layer thickness. The flow of raw material then continues along the conveyor, moving further into the facility. Inside the factory, the process begins with crushing the sugarcane to separate the juice from the fiber. The cane stalks are fed into a massive crushing unit consisting of multiple pairs of counter-rotating steel rollers. Exerting hundreds of tons of pressure, the rollers crush the stalks and break down their internal fibrous structure to extract every drop of sugar-rich juice. A stream of golden brown juice flows continuously into collection troughs and is pumped to the sugar production area. Once the cane has been thoroughly squeezed, all that remains is a mass of dry fiber known as bagasse. Since the main focus here is sugarcane bagasse-based paper, I will concentrate on the bagasse. However, if you are interested in the sugar production process itself, do stay tuned for the latter part of the video. It's quite fascinating. Immediately afterward, the bagasse is transferred to a specialized chain conveyor system. Steel scrapers attached to the chain links continuously rake and lift the layer of porous bagasse upward in stages, facilitating the transport of this lightweight yet high-volume material without causing blockages. Afterwards, the sugarcane bagasse travels along a conveyor belt to a collection area outside the factory. There, it is piled into massive heaps, sometimes as tall as a building, awaiting transport by truck or specialized container to paper manufacturing plants. The sugarcane bagasse is rapidly transported to the independent paper mill, where excavators scoop it onto processing conveyor belts. There, it begins a remarkable transformation journey into pristine white paper. First, the bagasse must go through several cleaning stages. A series of washing systems removes the soft pith, along with dirt, sand, stones, and other impurities left behind after harvesting and sugar extraction. This step produces cleaner cellulose fibers, while also protecting the downstream equipment from excessive wear. Once cleaned, the bagasse is fed into a digester, essentially a giant industrial pressure cooker. Inside, it is cooked with caustic soda, steam, and water under high temperature and pressure to dissolve the lignin and release the cellulose fibers. Lignin is the natural binder found in plant cell walls that holds the cellulose fibers together and gives the sugarcane its structural strength. The entire cooking process, including the precise addition of chemicals, is automatically controlled by a computerized system. Subsequently, the pulp must pass through a massive rotary drum system. Here, water is continuously sprayed onto the surface to wash away any remaining impurities, while scraper blades divide the pulp layer into narrow strips, facilitating faster and more uniform water drainage. Upon exiting this unit, the pulp has reached the required consistency and is ready to be pumped directly into the paper machine to begin the formation of the initial paper sheets. After cooking, the pulp is washed several more times to remove the dissolved lignin along with any remaining caustic soda. By the end of this stage, most impurities have been eliminated, leaving behind clean cellulose fibers. This is the preliminary paper that has been formed. However, it still retains the color of the sugarcane fibers, so bleaching is required to whiten it. The pulp is then bleached to transform its natural brown color into bright white. This process takes place in 3 separate stages. First, chlorine dioxide removes most of the remaining lignin. After another washing stage, the pulp is treated with a mixture of hydrogen peroxide and sodium hydroxide. Finally, it undergoes one last hydrogen peroxide treatment, producing clean, uniformly white fibers. Next, the bleached pulp is blended with hardwood and softwood pulps in proportions that vary depending on the type of paper being produced. This mixture is known as the furnish. Fillers, such as clay or calcium carbonate, may also be added to improve brightness, opacity, and smoothness. The furnish is pumped into the paper machine. At this stage, the mixture is still about 98% water. Inside the head box, it is evenly sprayed onto a moving wire mesh with millions of tiny openings. As water drains through the mesh, the cellulose fibers remain on the surface and begin bonding together. The amount of pulp deposited at this stage ultimately determines the thickness of the finished paper. As the wire continues moving, water is rapidly removed, while the cellulose fibers interlock more tightly with one another. Within a short distance, they form a continuous wet sheet known as the paper web. The paper web then enters a massive drying section. It passes through a series of press rolls and steam-heated cylinders, which remove the remaining moisture and dry the sheet to a precisely controlled moisture content. Every parameter is carefully adjusted to meet the specifications of the final product. Before being wound into rolls, the paper passes between two polished metal rollers to create a smooth surface. At the same time, an electronic scanning system continuously checks the sheet for thickness variations and other quality defects. The finished paper is wound into enormous rolls weighing more than 6 tons, known as jumbo reels. When one reel is full, the machine automatically transfers the moving paper sheet onto a new empty core without stopping production, allowing the entire process to run continuously. In the final stage, large paper rolls are fed into an automated cutting system, where they are trimmed into standard-sized sheets, such as A4. Before packaging, each sheet undergoes a fully automated process involving surface inspection, the removal of defective products, and quantity counting. Finally, the reams are wrapped, boxed, and ready for shipment to consumers. Following up on my earlier mention of the sugar production process, let's return to the sugarcane juice used to make the sugar. After extraction, the juice moves on to the concentration stage. Here, the water is evaporated over 3 hours at 130 degrees Celsius. This raises the sugar concentration from roughly 20% to nearly 70%, transforming the dilute juice into a thick sugar syrup. The sugar syrup is then fed into a vacuum crystallizer to concentrate the sugar to saturation. Engineers add seed crystals to initiate the crystallization process. Under controlled temperature and pressure conditions, sugar crystals form gradually and settle at the bottom of the vessel. After crystallization, the sugar crystals remain coated in a layer of molasses, giving them a brown color. This mixture is fed into a centrifuge, spinning at approximately 1/500 revolutions per minute. The resulting centrifugal force is strong enough to drive the liquid molasses through small perforations in the drum wall, while the sugar crystals are retained inside. Following this stage, the sugar appears lighter in color and proceeds to the drying phase. After this step, the sugar crystals still retain a certain amount of moisture. Consequently, they are fed into a hot air drying system operating at approximately 80 degrees for 30 minutes to remove the remaining water without causing the sugar to melt or clump. Once dried, the sugar is transferred onto a conveyor belt to cool and is then transported to the packaging area. Finally, the finished sugar is fed into an automated packaging system. Conveyor belts continuously transport the sugar to specialized packaging machines, where the product is weighed, bagged, and sealed with high precision, while meeting strict standards for hygiene and food safety. Do you think paper made from sugarcane bagasse could completely replace wood-based paper in the future? Or is there another material capable of replacing wood and saving the vast forests that are cut down every year? Feel free to share your thoughts. And if you enjoy exploring the inner workings of modern factories, don't forget to check out Mido Explained. Goodbye, and see you in the next videos.